So I'm going to go through the algebra approach for how to solve for particles when you have moles. So reading this problem, we see we have a balanced equation, and we see we are provided with 2.5 moles of iron, and we're asked about the particles of the iron 3 oxide. So we start by doing the very beginning steps, which is labeling what we have and what we don't have. So the 2.5 moles of iron go up here. So we're going to go up there and we're going to label 2.5 moles of iron. And then we're going to go over to the iron oxide and we're going to put X, but this time we're going to put particles. Okay, and it's important to put particles because we have particles this time. Okay, so next step is to drop our coefficients. So the 4 and the 2. All right, and then because it says mole here, we're going to multiply our coefficient by 1 mole. But this time it says particles. So when you're multiplying by particles, you're looking for Avogadro's number, 6.022 E23. And remember, this key on our calculator means times 10 caret. So on your calculator, if it's one like mine, it'll be EXP. If it's a TI 80 something, it'll be the second comma button. So now we set this up into our proportion. So on the top left, we have 2.5. On the bottom, 4 times 1 is 4. On the top up here, we have X. Down here, we have 2 times Avogadro's number. So in our calculator, 2 times 6.022 E, let me type that again, 22 E23 comes out to 1.20 E24, and you have to look carefully at your calculator so you see that it's not just 1.20. So next step would be to cross multiply. So I'd end up with 2.5 times 1.20 E24 equals 3E24 divided by 4. And we end up with X equaling 7.50 times 10 to the 23. On my calculator, this looked like E, right? So I saw 7.50 23 on my calculator, but it means this. We go look for X, and X is telling us particles of Fe. So of Fe, so particles of Fe2O3, iron 3 oxide. So this is our final answer. So this is how we would go from moles to particles. Okay.